before we get to solving applications, which is the last thing in this section, I want to talk about a couple of things first. The first thing I want to talk about is percentages, because some of our applications involve percentages, and so it's important you understand them. It's important that you understand the relationship between a percentage, a fraction, and a decimal. Percentages, again, is usually how we talk about things. I got an 87% on a test. Percentages can be written as fractions or decimals, and actually when you do math, multiply, whenever you use them, you always make them convert the percent to either a fraction or a decimal. And to do that, to get to the fraction, you divide by 100. And you take your percent divided by 100%, it'll give you your fraction. And you reduce it, it'll give you a reduced fraction. Or divide it out, and it'll get your decimal. So example, and we'll go both directions. Suppose I have a 68% and I want to convert it to the decimal. Well, you take your 68% divided by your 100%. If you want to leave it as a fraction, you'd reduce it to 17 over 25. Or you can divide it out, and it's the decimal 0.68. So again, we're dividing by 100, so it should make sense the decimal place is going to move over twice. So same thing if I have a negative percent, right? I'm moving down, so 24.6. Right, same thing, I take 24.6, divide by 100. If I write that as the reduced fraction, so I hit my fraction key on my calculator, it's 33 out of 125, or if I divide it out, it's, write my negative 33 over 125, or negative 0.246. Again, just moving the decimal place over twice, right? So it works in reverse. So if I have the decimal 0.121, I can rewrite that as the percent. Well, you can think of it as working in reverse. You multiply by 100. I take 0.121 times my 100% to get my percent out. So it's 12.1%. Or negative 0.73. Same thing. Negative 0.73 times 100% comes out 73%. Excuse me. You can even go over 100 if you wanted to. Suppose 1.56, what you're looking at. Well, I take my 1.56 times my 100 still, though, and it's just going to come out to 156%. All right, and so what we're looking at here, again, just so you understand what fractions and decimals are, before I get to the applications, I'm going to go up here and kind of talk about it. Remember what a percent is. It's how much you've completed. So if I'm looking at a test score, and I got an 87% on an exam, all right, the exam had 250 points. Well, that means you got 87% of the 250 points. And so to figure out how many points you got, you would take 250 not times 87. You always have to convert it to its decimal. And so you'd multiply it times the 0.87, right? Dividing it out by 100, so move the decimal place out twice. And so you take your 250 times your 0.87, and that means you got 217 and a half points. And to check your answer, you can always check it. Always take part divided by whole. So the part is the part you got right, which was the 217 and a half. Divide by 250, all right, should give you 0.87, your 87%. All right, so that's how percentages are used. So we're going to look at a simple application with a percentage in it. All right, so a simple application is, suppose a survey found that 76% of bicycle riders do not wear helmets. All right, find the formula for the function that computes the number of people who do not wear helmets among X. So X represents the number of people who are riding bikes, right? That's what X represents. X is number of people. 76% of all people do not wear a helmet. Right, so we want to find the function that computes 76% of X, right? 76% of the people. Well, it's not 76 times X. That would be wrong. It's the decimal 0.76 times X. will give me the percent, or give me the number of people. So again, if 100 people were riding bikes, we know 76 of them should be not wearing helmets based on statistics, right? If you take 100 times 76, and that way would be. And so now we're going to look at an example. Suppose there are approximately 38.7 million riders of all ages, all right, who do not wear helmets. So again, they're telling me who are not wearing helmets. Find the total number of bicycle riders. So I'm looking for X, right? X represents the total number of bicycle riders. They're giving me the function value, right? The function tells me how many don't wear helmets. So I want to solve for X actually in this case. I take my 38.7 million, or keep in mind it's in millions, set it equal to the equation I found up here, 0.76x, right? Because I want to always understand what you're given and what you're asked to solve for. I'm given the function value. The function represents those who aren't wearing helmets. That's what I'm given. I'm asked to find the x value. How many people were bicycle riding? If 38.7 million of them weren't wearing helmets, and I know that's 76% of the people who were biking. And so you take your equation, set it equal to that value, and then you solve. Solve for x. All right, using our methods from before, which would mean I need to divide out that 76.76. So you take your 38, divide by 0.76, and it comes out 50.9, remember it's million, is the x value. And to check yourself, you could always check your answer. Never a bad idea to check it. If I take my 38.7 people who don't wear helmets, divided by the total number of people, right, it's always part divided by whole, I should get 76, and I do, so you can kind of check your answer. Always provide units with your answer, so the answer is, since again it is still an estimate, 50.9 million people ride bicycles. Of the 59.7, 76% are not wearing helmets, and that comes out to 38.7 million people out of 50 million, or almost 50.1. Alright, so that's just kind of, we'll do more examples. We're going to do a mixture problem in a little bit, an application where we'll involve mixtures that will have percents in it as well, but you should always make sure you understand percents. Alright, percents are going to show up in a lot of applications, so make sure you know the percent of something. You take the decimal of that and multiply it by the something. When you're checking your answer, it's always the part, the smaller part, right? The value part, not necessarily the smaller. It's always the part we're interested in. Like this case, we're interested in the people not wearing helmets, divided by the total, how many people there were. All right, so I'm going to wrap that video up here.